Mathematics. Today we are still on the MIT Integration Bee 2026, and we'll be focusing on the semifinals. Semifinal number 1, specifically problem number 3, which is the definite integral from x equals to 0 to x equals to pi of the minimum, where a is an element of a set 0 and 1, of a maximum where b is an element of a set 0 and 1, of minimum where c is an element of a set 0 and 1, of cosine, open bracket, a plus b plus c times x with respect to x. So this is a very interesting problem. I hope we hang around and see how we may be able to solve this problem here. The first thing we would want to do is let's extract the integrand, and that is the function under the integrand sign, the integral sign, and we call this integrand fx, right? So let fx be equal to what is under the integration sign, and then we go and look at the innermost expression, and we call that g of a, b, and x, which is the minimum of between when c is 0 and when c is 1. So g a b x is the minimum of cosine a plus bx when obviously c is 0, and cosine a plus b plus 1 times x when c is 1. And then we can now go further and say, okay, we have h, which is a function hax, which is a maximum where when between when b is 0, so g of a 0x, and g a when b is 1, g a 1x. So we are employing this initial function here. And then the final function, fx now, is the minimum, taking this minimum, when a minimum between when a is 0 and when a is 1. So h0x and h1x. So that is how we're going to approach it. We're going to begin from the very top and then figure it all the way down until we get the value fx. So it's a very interesting problem, and without much ado, let's keep figuring this out. So this is the summary of where we've reached, and let's begin when a equals to 0. When a is equals to 0, this h here, we have a maximum of g 0, 0, and when we have b equals to 1, so g0, 1 of x. Now, what does that mean? That means that we are looking at two situations inside, which g0, 0x is a minimum of cosine 0 and cosine, we have 0, 0, 1, so cosine of x. So what is the value of minimum between cosine 0 and cosine x? And then since we're looking at the maximum function, g0, 1x is the same as minimum, right, of when we have 0, 1, and x. So we have 0 plus 1 here, we have cosine x, and then when we have 1, 1 x, so we have cosine 2x. So since cosine 0 is just 1, so we'll have to find a minimum between 1 and cosine x, and since we know cosine x is always going to be less or equal to 1, so cosine x transits here, And then when we look at the minimum between cosine x and cosine 2x, we will have to break it into two subregions. So we've already found that between 1 and cosine x is the minimum, but between cosine x and cosine 2x, it's not entirely straightforward. So we will see that when x is less than 2 pi over 3, cosine 2x is greater than cosine x. And then when x is greater than 2 pi over 3, cosine x is less than, rather, cosine 2x. So here, cosine 2x is less than cosine x when x is less than or equal to 2 pi over 3, and when x is greater than 2 pi over 3, cosine x becomes the minimum. Now we have to we need to now derive the maximum between cosine x and cosine 2x, right? In that domain, obviously cosine x is maximum, since we've already found out that cosine 2x is minimum, is below cosine x in this domain. And then here, since we have cosine and cosine x, so cosine x comes out. So when a equals to 0, h0x is going to be cosine x. Okay, and h0x is definitely g00 x and g01x, the maximum between those two. And so we have now ascertained this first part here. And believe you me, this is just the beginning. So let's continue. What about when a equals to 1? When a equals to 1, that means h1x is the maximum between g10x and g11x. What is g10x? g10x is the minimum between cosine x and cosine 2x. And g11 is the minimum between cosine 2x and cosine 3x. So we have to plot this thing out. So cosine x is the blue, cosine 2x is the orangish, and then cosine 3x is the purple. And as you can see, we can split this into probably 1, 2, 3, 4. So 4 subregions. So between 0 and 2 pi over 5, we see in this first, the minimum between cosine x and cosine 2x, cosine 2x is minimum in that region. And the minimum between cosine 2x and cosine 3x, cosine 3x is minimum. So we are going to, in that region, we have a maximum between cosine 2x and cosine 3x, right? And in the domain 2 pi over 5 to 2 pi over 3, we see that the minimum between cosine x and cosine 2x, cosine 2x is still minimum, and then cosine 2x and cosine 3x, cosine 2x now becomes a minimum. Now between 2 pi over 3 and 4 pi, minimum between cosine x and cosine 2x, we see that cosine x is minimum, and the minimum between cosine 2x and cosine 3x, because the purple has already gone up here, we see that cosine 2x is minimum. Now from 4 pi over 5 to pi, we see that minimum between cosine x and cosine 2x, we see cosine x is minimum, and then between cosine 2x and cosine 3x, we see that cosine 3x now flips back to be minimum. Okay, so we have to evaluate these independent functions. So we have this plot that we want to keep cosine x, cosine 2x, cosine 3x, and we had this expression which we need to solve. So between cosine 2x and cosine 3x, in this first subinterval, we see that cosine 3x is cosine 2x is maximum in that region, right? And then since we have cosine 2x here, in that region we have cosine 2x, and between 2 pi over 3 and 4 pi over 5, between cosine x and cosine 2x, we see that cosine x between 2 pi over 3 and 4 pi over 5, the maximum between cosine x and cosine 2x, this region here, we see cosine 2x is maximum. Now, from between 4 pi over 5 to pi, between cosine x and cosine 3x, we see that cosine 3x is above the blue. Okay, that's important for us. So now what do we do? H0 is x, H1 x is cosine 2x in this region, and cosine 2x in this region, and cosine 3x 2x in this region, and cosine 3x. But looking at our graph now, our fx is a minimum between h0x and h1x. So in all this region, we're going to be comparing cosine x and cosine 2x, cosine 2x, cosine 2x, cosine 3x. So in this entire region here, what is minimum? What is minimum is cosine 2x up to 4 pi over, up to 2 pi over 3 rather. Okay, so fx is cosine 2x from x equals 0 to 2 pi over 3, and above that cosine x becomes a minimum. So our integral now reduces to a two-part integral where we have an integral of cosine 2x from 0 to 2 pi over 3, and then an integral of cosine x from 2 pi over 3 to pi. So cosine 2x integrated is half sine x, sine 2x rather, from 0 to 2 pi over 3, and then cosine x integrated is sine x. So substituting in the limit, we have half sine 4 pi over 3 minus sine 0 plus sine of pi minus sine 2 pi over 3. Sine 0 is 0, sine pi is 0. So sine 4 pi over 3 is negative 3 over 2. So times obviously a half here. So we have negative half times root 3 over 2. And then sine 2 pi over 3 is going to be equal to pi over 3, but we have a minus here. That minus kicks in, and so we have negative 3 root 3 over 4, and that is our answer. So a very interesting problem. I hope you enjoyed. If you have any question, please don't hesitate to reach out to us. We'll be very glad to walk you through any questions you may have. Here at Everyday Mathematics, we do enjoy mathematics. We do enjoy solving these seemingly hard problems, and we would like to share with you our passion for mathematics. Until next time, bye-bye.